Hello, Cloud Gurus, and welcome to this lesson. In this lesson, we're going to take a look at IAM policies in a bit more depth. A previous lesson covered IAM users, groups, policies, and roles. This lesson covers IAM permission boundaries and how AWS evaluates IAM policies. So let's get started. The first thing we need to understand when working with IAM policies is the Amazon Resource Name, or ARN. The ARN uniquely identifies any resource in AWS. They have an interesting syntax, and we're going to break that down for you now. All ARNs begin with a string that looks like this: ARN, a partition name, service, then region, then account ID. So what do all of these pieces mean? Well, ARN is exactly what it says, the ARN. And then we have the partition. So you might not know this, but AWS actually has different partitions that it operates. The most common one is AWS, the one that you're familiar with. But if you're working in the China region, for example, that's a completely separate infrastructure called the AWS-CN partition. You're not going to see it unless you work with AWS China. But just understand that that exists. Next, we have a service, and that's any of the AWS services like S3, EC2, RDS, DynamoDB, and so on. Then we have a region. So these are any of the AWS regions like US East 1, EU Central 1, and so on. And then finally, you have your 12-digit AWS account ID. So all ARNs begin with a string that follows this structure. And they end with something of the form resource or resource type and a qualifier. So I realize this is super confusing and it makes no sense without an example. So let's take a look at some of those. So let's take a look at this first one here. This is an IAM user. So it starts with ARN, AWS, and then the service name, IAM, and then we have two colons. Well, why do we have two colons there? Well, IAM is a global region, meaning it doesn't exist in a particular region. So this is actually an omitted value. So we just skip over that value using two consecutive colons. Then we have our 12-digit account ID, followed by a resource type / resource. So in this case, the resource type is user, and the resource is Mark. That's me. So this ARN uniquely identifies my IAM user Mark within my account. Let's take a look at this next example. This is the ARN for a specific object inside of a bucket in S3. So we have ARN, AWS, the S3 service, 3 colons, because there's no specific region or account ID needed to uniquely identify an object within S3. Remember, all bucket names in S3 are globally unique, so you don't need those additional qualifiers for uniqueness. So we have the bucket name / object name. Let's take a look at another one here. This is a single table within DynamoDB. So we have ARN, AWS, DynamoDB, the region name, because DynamoDB is a regional service, our 12-digit account ID, and then our resource type, which is table, / resource name, which is orders, the name of our table. Let's take a look at one last example here. We can use ARNs to specify not just a single resource, but all resources of a particular type. So say we want to refer to all of the EC2 instances within a single account in a region. We would have ARN, AWS, EC2, US East 1, because EC2 is a regional service, our 12-digit account ID, and then our resource type, which is instance, followed by /star. And we use a star as a wildcard. This represents all EC2 instances in that account in that region. So next we have IAM policies. A policy is simply a JSON document that defines permissions. And we have two types. We have identity policies, which are attached to an IAM user, group, or role. These policies let you specify what an identity can do. In other words, its permissions. And then we have resource policies. Resource-based policies are attached to a resource. For example, you can attach resource-based policies to S3 buckets, SQS queues, KMS encryption keys, and so on. With resource-based policies, you can specify who has access to the resource and what actions they can perform on it. Now, it's important to understand with IAM policies, just because you've created a policy doesn't mean it has any effect. You have to attach that policy, either to an identity or to a resource. So unless it's attached, it has no effect. And policies are simply structured as a list of statements. The basic format of an IAM policy looks like this. This is a JSON statement, and it all starts with a version number. The version number helps AWS identify the structure of the document. At the time of this recording, it's always going to look like 2012-10-17. And like I said, a policy document is simply a list of statements. That's what the square brackets represent, an array or a list. Each individual statement is enclosed in curly braces. So you can see here this outlines 3 statements in our policy. Now each statement matches an AWS API request. What's an API request? So that's really any action that you could perform against AWS. So for example, when we start an EC2 instance, that's an API request. Create a table in DynamoDB, that's an API request. Or get an object from S3, that's also an API request. So let's look at a more concrete example. So our IAM policy can start with something called SID. That's really just a human-readable string that's to tell you what this statement is for. Next, we have an effect. It's either allow or deny. Our IAM policy can either allow or deny specific actions on a specific resource. So this particular IAM policy obviously works with DynamoDB. And this policy is matched based on these actions. So actions are of the form service name : action name. And you can see some of them have wildcards at the end in the form of a star. So that refers to any API request that starts with that string. So batch get star, batch write star, delete star, update star, and so on. And then finally we have the resource. That's the resource that this action is against. So this IAM policy allows all of these actions to this particular resource, in this case, a table called myTable. So let's take a look at creating and applying an IAM policy. So here I am in the AWS Management Console, and we want to go to IAM. Okay, so let's get started by creating a policy. Here I am in IAM, and we'll go to Policies. Now we have 2 types of policies in AWS. We have AWS Managed Policies and Customer Managed Policies. The AWS Managed Policies are ones created by AWS for you for convenience, and they're denoted with this orange box icon here. These are not editable by you, but you can use as many as you like. And then we have Customer Managed Policies. So ones like these here that I've created for specific purposes. We're going to create our own Customer Managed Policy. Now we can either use the visual editor or directly input them using JSON. I always directly input them using JSON so I can understand exactly what they're doing in detail. So let's go ahead and delete this boilerplate, and I'll paste in a statement that I've already prepared. And I'll walk you through what this means. So what we want this policy to do is allow a number of actions against a bucket in S3. So we have 2 statements here. The first statement, the effect is allow, the action is the S3 list bucket API, and the resource is against a bucket called test. Now it's a foregone conclusion that the bucket name test has already been used, but I'm just going to use this as an example. This statement is going to allow whatever user, group, or role has this policy attached to list the bucket name test. That is, show all the objects in that bucket. We have a second statement here that's going to allow these 3 API calls against objects in that bucket. Put object, which is to upload an object to S3, get object, which is to download an object from S3, and delete object. You'll notice our ARN is of a slightly different format, where after the bucket name we have /star, that wildcard we talked about. Because these 3 API calls operate on the object level, and we want them to apply to all objects within this bucket, we use /star as that wildcard. So list all the contents within the test bucket, and put, get, and delete all objects within that bucket. All objects of any name /star. So let's review our policy, and we'll just call this S3 policy. You can give it a description if you like. I'm not going to do that right now. And you can see it gives you a summary. So the service is S3. The access level is limited list read and write on multiple resources. And we'll create our policy. So remember, just because we've created a policy doesn't mean it has any effect. We need to attach this policy to something for it to be effective. So let's attach this policy to a role. We'll go to roles, and you can see I have a number of roles for all different purposes here. Let's create a new role, and let's say, for example, we want to allow EC2 instances access to that S3 test bucket and those 3 API calls that are in our policy. So we'll select AWS Service, EC2, select Permissions, And here's where we type in the name of our policy. S3 policy. This is the policy that we just created. If we expand that, we can verify that it is indeed the JSON statement that we entered. We'll select tags, review, and we'll call this S3 role. You'll probably want to give it a much more specific name, but for the purposes of this demonstration, that'll suffice. Just make sure that the S3 policy is attached here, and we'll create our role. So now our policy has effect. If you attach this role to any EC2 instances, it will implicitly be granted access or denied access based on what that policy contains. So in our case, any EC2 instances that have this S3 role attached will have the ability to list objects within that test bucket, as well as get, put, and delete objects from that bucket. So let's go back to this role, and I want to show you two more things. Here we can attach a policy. Let's attach a manage policy. So we'll click Attach Policies. So let's say, for example, that EC2 instance needs to do more than just access that S3 bucket. Let's say it needs full access to, say, all of DynamoDB. So we'll do search for DynamoDB here, and we want to grant it DynamoDB full access. Now, instead of creating a full IAM policy specifying all the different permissions that we're going to need, we could simply choose this AWS Manage policy here. This is a predefined set of permissions that's going to do everything that we need without having to manage that policy. So we'll click Attach Policy. And now we have this Manage policy alongside our customer-defined policy here. Now let's say, for example, we want to grant some special permission to this role, but we don't want to define a policy that really lives outside the scope of this role. That's where we'll use inline policies. Here, inline policies work just like any other kind of policy, except the scope is limited to just this role. You can't use this inline policy with any other role. You'll typically use this with any kind of ad hoc permissions management that you're doing, but it's typically not a best practice to use an inline policy like this. Okay, so let's take a look at some exam tips. Now, one thing that's absolutely critical to understand about IAM policies is that any permissions that are not explicitly allowed are implicitly denied. So if your identity or resource doesn't have a policy that explicitly allows an AWS API action, it's implicitly denied. If you have a policy that's an explicit deny, that overrides anything else in any other policies. So for example, if you have a policy that allows access to an S3 bucket, but another policy that explicitly denies access to that same or all S3 buckets, the explicit deny will always override. And remember, only attached policies have an effect. Just because you've defined a policy doesn't mean it's doing anything until it's attached to a user, group, or role. And when you have multiple policies attached to either an identity or a resource, AWS will join or union all of those policies together when it performs its evaluation. So if an action is allowed by an identity-based policy, a resource-based policy, or both, then AWS allows the action. An explicit deny in either of these policies overrides the allow. Also understand AWS managed versus customer managed policies. So now let's talk about permission boundaries. This feature can be used to delegate administration to other users. So if you have system administrators that need to be able to create IAM roles and users, developers that need to be able to create roles for Lambda functions, or any similar scenario, then you need permission boundaries. AWS supports permission boundaries for IAM entities, so users or roles. A permissions boundary is an advanced feature for using a managed policy to set the maximum permissions that an identity-based policy can grant to an IAM entity. These are used to prevent privilege escalation or unnecessarily broad permissions. An entity's permissions boundary allows it to perform only the actions that are allowed by both its identity-based policies and its permission boundaries. In other words, it controls the maximum permissions an IAM policy can grant. So some use cases for this: developers that create roles for Lambda functions, application owners creating roles for EC2 instances, or administrators creating ad hoc users will want to apply a permissions boundary in each of these cases. So let's switch over to the AWS Management Console again, and I'll show you how this works. So let's say we have our IAM user here, Ryan, and Ryan has the directly attached AWS Manage policy administrator access. So as it stands right now, this user, Ryan, has full access to all features within this AWS account. But let's say, for example, we want to limit his access to just DynamoDB. Well, we can apply a permissions boundary to do just that. If we expand this here, permissions boundary says it's not set. We'll want to set the boundary. So let's select a manage policy, DynamoDB full access. Click set boundary. And it says permissions boundary Amazon DynamoDB full access has been set for Ryan. So now, even though we have the administrator access policy directly attached to this user, the permissions boundary is going to govern the maximum permissions that this user has. So even though he's an administrator, he can only work within DynamoDB while this permissions boundary is set. So I hope that makes sense to you, and it's worth a few points on the exam, so I encourage you to play with this in your own account. So that's it for this lesson on IAM policies. Thanks, and I'll see you in the next lesson.